So now we will look into the nature of energy bands, and let's try to explain the electric nature of insulators and conductors and also semiconductors. So first, let's look at the energy band of insulators. So for insulators, it looks something like this. So we have an energy band here, and we have another band way beyond here. So in this is where all the valence electrons of the molecules inside insulators are situated. So this is called the field valence band. So all the valence electrons of the insulators lie in this area. Now, the next allowed energy band for these electrons is called the conduction band. So this conduction band simply means that if we apply an electric field to electrons here, we give them electric fields, they will jump into the conduction band here. But the trouble is, this electric field doesn't provide that much energy, or it cannot provide enough energy so that these electrons in the valence state can jump from this energy band to the next energy band. So this is the property of insulators. That is why they cannot conduct electricity. So their valence electrons have very far separation between the conducting region from the valence region. Now let's take a look at conductors. Or most metals. So for most metals, their valence band, this is their field this is their field valence band, and their conduction band is very near to the field valence band. In other words, if we have electrons sitting here at this energy state, apply just a small amount of electric field or apply just a small amount of energy, they can easily migrate into the next energy state, which is the conduction band. That is why conductors can conduct electricity very well. Now, let's take a look for the case of semiconductors. This is their field valence bands. Now, for semiconductors, it's like sort of the in-between of insulator and conductor. Now, if your electrons are sitting here in the valence bands, if you apply just enough energy or electric field, just enough electricity to these electrons, there is a probability that they can jump from this state to the conduction band. So that is why they are called semiconductors. They can conduct electricity, meaning they are, of course, conductors, and they have a property also that they are insulators. So if the energy is not enough, they behave like insulators. If the energy is enough, they behave like conductors. Now, semiconductors actually revolutionized all of our current technologies that deals with circuits. So these semiconductors are the basis of transistors, diodes, and so much more. So needless to say, they are the ones responsible for the operation of smartphones, computers, anything that has to deal with electrical components.